Good evening. How are you?
Good, how are you?
I'm good. Good. Thank you. Hi, Nicola. So let's start this session. This is only an introduction for the uh, research course, okay? And I need you to select your project. Okay. Today, I introduce the projects to you, and maybe today or during the next few days, you select your project. You have 3 weeks to perform a literature search and review on this project to see what it means in the literature and what other researchers have done before about it. And then after 3 weeks, we meet again and review what you have found on your project. We present your project one by one about the literature findings, and we discussed the methodology and design of your research. Then you have 2 or maybe 3 weeks for working on this uh, research method to finalize it. And again, we meet again after 2 or 3 weeks to discuss your method. And when we design your method completely, then we can move on to perform the research. The rest of the semester is for performing the research. I don't expect your research to be finished by the end of the semester. You have another semester for you to continue it, but uh, we will have some meetings, maybe 1 or 2, to discuss your project. And then at the end of the semester, you will present what present your findings, and your evaluation will be based on the new sessions that we have presented your findings, your literature review, your method, and that's it. So this is how it will work. So I think for Monday, during the semester, we will have, except for this session, we will have 4 or maybe at most 5 sessions. These are the list of the projects that was included in the syllabus, and I ask you to review them to be familiar with them. Before you making any selection, let me explain one by one for you to see what we expect from this project. The first one, we want to to design a material that is as rigid as a stainless steel, but as flexible as vertical bone. Vertical bone is very rigid, but not as rigid as a stainless steel, but it is rigid enough for whatever we need to do. But as we discussed before, these properties of the vertical bone is because of its microscopic structure. And with our current technology, we cannot produce that microscopic structure. So that is why we use metal to replace the vertical bone, because metals are the only material that are rigid enough to replace the vertical bone. They are fatigue resistant, they are corrosion resistant, they have all the properties, but they lack one property, and that is the flexibility of the vertical bone. Flexibility and stiffness are the same concepts from reviewing from two opposite sides. They have the same physical meaning, but the stiffness talks about how deep a material is. Flexibility talks about how flexible a material is. So they are looking at the same property from different views. So when we talk about the stiffness or flexibility, they are the same thing. To change the stiffness of a material, we have two ways. One is to change the material. The other one is to change the structure. With all the metal and metal alloys that are currently known, you don't have any metal or metal alloy that has flexibility near vertical bone. The nearest one is titanium and tantalum, but they are still much more stiffer than vertical bone. So changing the metal itself doesn't work. You may say we can use some material that are, for example, composite material, or we can use polymer, but they are not fatigue resistant, they are not corrosion resistant, some of them are biodegradable. So in this specific research, the intention is finding a structure, microstructure that is still rigid, but is also flexible. So you may be familiar with the concept called metamaterial. Metamaterial is a material that is not found in nature. We have designed it. The nature didn't design it, but it has a repeatable or repeating microstructure. When you have a cut of this material, you see this cut is repeated, and this repeating units form that structure. This is called metamaterial. Something like a metamaterial. You need to design a material structure, microscopic material structure, not microscopic, must be macroscopic, but very tiny material structure that has the rigidity compared to a stainless steel, but flexibility compared to uh, cortical bone. So first you need to define the rigidity and strength and toughness, then you need to define the flexibility and then design different structures that can match these properties. And then test them. Almost all these projects, except the last one, can be done by SolidWorks software. The next one is optimal fixation design for femoral neck fracture.
Quick question, Professor. Did you say that we have to design the material in SolidWorks and test it? Is that what you were saying? Okay. Just double checking.
Yes. Have you worked with SolidWorks?
Yes.
Yeah. All of you? You're familiar with SolidWorks? Okay, that's great. So there's no need to review the SolidWorks. If I have any question about SolidWorks, I can ask you. In the second one, we will have a model of the femur, a 3D model of the femur, and we create, we have in the femoral neck area, we have different patterns of fracture. For each pattern, we design different fixation construction. For example, 3 screws, 2 screws, 3 screws in different direction and different 3 screws in parallel direction. And also the size of the screws, the amount of the threads in the screws. We design this structure and then we use the SolidWorks or no, SolidWorks is good for it. We use the SolidWorks for simulating the structure and finding which one is more stable. And in this way, we can perform several simulations for the different fixation construction in the femoral neck. You can draw the screws. I can give you a sample file and I can, if you want, I can explain, but I'm sure you know better than me and YouTube is much better feature than me. So I can give you a sample file for the screws and I will give you the 3D femur file and then we can work with that. The next one is the same research for fracture in distal radius. The third one is the same research for fracture in the proximal tibia, distal to knee joint. These are the fractures that have huge controversy in literature. You still don't know the optimal fracture method, the fixation method for this fracture. We have lots of different plates, different designs, but we don't have any idea for the fixation pattern of choice for this fracture. And another research is optimal fixation method for humerus fracture. This is the same one, but it uses some plates. Now for the proximal tibia needs some plates. So these four research topics are similar, but for different bones. And don't worry, whatever file these topics need, I will provide those files. You may need to change those files based on your computer and based on what you want to do. whatever you want, you can do into a file, but you have you will have the basic file. So don't worry about designing a plane in SolidWorks. I will give you the original file and you can make something. And the bones that I will give you are extracted from CT scan. And if your computer has 64 gigabyte RAM, we can work with them in SolidWorks. But if you have a smaller RAM, you have to simplify those files. Because you will see the files that are extracted from CT scan have lots of faces and nodes. So the SolidWorks takes a long time to work with them. You can simplify them. Or even when you have the file, you can grow a simple file in SolidWorks similar to that one. Another research design is designing a hip joint or knee joint for exoskeleton. The current exoskeleton, which are designed over the body, they are for wearing over the body like clothes. So the joints are outside the body in exoskeleton. For joints that have different motion, this exoskeleton have a huge problem. For example, consider the elbow joint. The elbow joint is a hinge joint. It has only one motion, flexion and extension. So this flexion and extension can be replicated in the exoskeleton by another hinge. But for shoulder or hip, they move in all directions. So you must have a joint with 3 planes of rotation. And all these 3 planes must have a single center of rotation. Otherwise, they will compress or distract the original joint of the person. So the current joints in the exoskeleton, if you search the literature, actually they are designed by 3 separate joints for the shoulder joint or the hip joint. So for one joint, they had to design 3 separate joints with a single center of rotation. I want to see if we can simplify this, if we can do it in another way. Maybe we can design something that can work in a simpler way. The same thing is true for knee joint. The knee joint has the rotation and flexion and extension and abduction and adduction. And to perform all these motions, we need different joints for knee joint. So if we can design something that all work together for flexion, extension, abduction, adduction, distraction, it can be a good choice for exoskeleton. So this one, you don't have any original file except for the skeleton, but you need to do something that design something. The next one is finding a material that can work like vertical bone, but it is resorbable. This is the research that one of the surgeons in Virtua gave me. I included it if you are interested in this research. First, you must search and find a resorbable material that is as steel and as flexible as vertical bone, and then between, for example, 6 or 7 different materials defined. You must simulate the properties of those materials to see if they can work like for sculpture. And the last one is about 3D printing. I will provide the software for this research. It is something different. It is a software designed for simulation of the 3D printing process. And in this software, you can change all the factors for 3D printing. For example, the power of the laser, the speed or of the nozzle, the change in the thickness of the powder, the temperature in the chamber. You can change many factors, and so based on that, you will have a result in your mechanical properties that is present in the printed part. So each factor will provide a change in these mechanical properties. First, you must define the best properties for the femoral stem, which properties you need. And based on your research, you can, at the end, you can find the best printing condition to have a femoral stem printed without any post processing. You know, with current 3D printing method, we have to use a post processing to change the mechanical properties because there are many voids, many cracks, many grain boundaries, different problems in the 3D printed sample. But with this research, we want to find out if we can have a 3D printing condition that can provide us with a femoral stem that is ready to be implanted after experimentation. These are the suggested topics. So for these 8, you need only SolidWorks. But for the third one, there is another software that I can provide it for you. But this software, the software for the last research topic, only works on Windows. It doesn't work on Mac. If you only work with Mac, you cannot do it. So, are you ready to select your research topic now, or do you want to think about it?
I'm sorry, just a quick clarification. You said that the optimal fixations are recreating
Sorry?
designs to fix fractures, and then we're going to test it, correct? Compared to the optimal designs, which we're just making exoskeletons for the joints and just test to make sure it actually operates correctly. Am I wrong, or?
Uh, your voice is not clear. May you say it again?
I'm sorry, can you repeat that?
May you ask your question again? I didn't get it.
Wait, hold on, I get a better mic.
Oh, yeah.
So what I'm asking is just to double check. The optimal fixation options are to create a design for a fracture itself and to test to make sure that it can handle the stress, while the optimal fixation is to essentially create, or the optimal design, I should say, is to create functioning exoskeletons for the particular joints.
The optimal design for fixation design means the design of fixation construct that can handle the stress in the bone. For these two, the optimal design for exoskeleton, you need to design a joint for hip and knee that can handle all the motions in the hip and knee joint. This is a design for the optimal motion. This is a design for optimal stress handling and stress distribution.
Okay, thank you for clarifying.
And for any information that you need about the joints, about the bones, about the forces on the bones and joints, anything you need and it is not discussed in our code, I am available to provide it for you because I'm showing you about the details of the research. So tell me, if you want to think about them, you can think about them and get back to me one by one. Select your title. Or you can select today if you are ready. It's up to you. I don't want to force you to select today. But if you don't select today and you want to get back to me one by one, you may have some overlap and anyone who gets to me sooner have the choice.
I mean, I think I'm good to select today, but if everybody else needs more time, it can give more time.
Select.
I'd be fine to select today.
Okay, Jacob, you are the first.
Can I do the knee joint exoskeleton?
Okay, then you can.
And then could I do the hip joint exoskeleton?
Hip joint for event, correct? And
I think I'll select the optimal fixation for the proximal tibia fracture.
I'll do the optimal printing conditions for 3D printing femoral stem one.
you have a Windows computer, yeah?
Yeah, I'm good with it.
And can I do the resorbable material for the cortical bone?
Okay. So you have 3 weeks from now to search the literature and find out what the literature says about these topics and what other researchers have done before, okay? So our next meeting will be on Monday, September 13th. 30th, sorry, September 30th, the end of September, after 3 weeks, and be prepared to present your findings in 15 minutes, okay? Then we talk about the design of your research, and we will move on to the next one. Okay, for 3 weeks you have, you only need to search the literature and find out about these topics in the literature and the previous research that has been done on this document. Okay? It's 3 weeks enough. Good. Okay. So for next 2 Mondays, you don't have any session. We meet. Our next meeting will be at the end of the September 5th. Good. Meanwhile, if you have any questions, you can contact me and ask me anything you need about the topic. Okay. Any question? No?
Yeah, I got a quick question.
No.
First off, I was just curious, how do we access the recordings again for the lectures?
That is a very good question. I created a Google Drive share file for each topic. And after each session or the day after that, I will upload the videos there. But I have another idea I wanted to ask you. I can create a YouTube channel and I can upload these videos in the YouTube channel. So you don't need to download the videos because they have a huge, there are huge files and there's a lot of space in your computer. So I think it will be easier if I upload them to the YouTube channel and you can access them. Is it better for you or a Google Drive is better?
I think the YouTube would be fine.
Everybody's good in YouTube? Okay. So give me the files are currently in Google Drive. Okay, you can access them. I'll share them with you. There are 4 folders, each folder for one topic. But so you can access the last week sessions on Google Drive. But I will work on the YouTube channel and prepare the videos and upload them, and then I will share the address. I think that's a better way because with YouTube channel you can access the videos wherever you are and not without downloading the file. Okay. Any other question?
One more. Sorry. Yeah, the other thing I wanted to ask is, would you mind sending that? Because I remember you said for the hospital visit, there's a list of requirements we have to fill out. Would you mind emailing us that list?
Yes, I will send it next week.
Okay, thank you.
This week I will send your every information I have on you to the hospital, and I have the full list of that whatever they need. But I want to, if they have any updates on the list, they can give me, and then I will next. The most important thing is vaccination. And the vaccination and maybe we need some lab testing too for proof of some disease, for example, for TB or something like that. But it doesn't take long. So you have time to do that because the hospital will be at the end of November. I want to make sure that if there is any updates on the file that they gave me, because the file was sent to me in May, and I want to make sure that there is no update to that file. So I'm in contact with the hospital. As soon as they send it back to me with the final update, I will inform. Okay. Another question? We have lots of time. Okay, enjoy your evening. I will see you tomorrow at 6:30 for the other class, and don't worry, all the classes are not with me, but the beginning of the course, all the classes are with me. So as you move forward with other topics, you have other teachers, and you don't have to tolerate me every day. Okay, have a good evening, enjoy your time, see you tomorrow.
Have a good
Bye,
night.
Professor.
Thank
Have a
you.
good day, Professor.